Howdy folks, welcome back. I got to fix my compressor. I kind of wanted to show you how I'm doing it because from what I'm reading online about these Kobalt Chinesium compressors, I'll try to see if I can put the part number or model number rather in. It's on the back side. I forgot what it is now. This is a real common problem. What happened yesterday was, well, let me show you the pieces and I'll explain it then. This is the I guess you call it the regulator assembly, manifold. You know, there's really two regulators, so to speak, on a compressor like this. You have a maximum tank pressure, which is where it shuts off, and that's not what this is. That's like a contact point where it gets a certain pressure and it breaks the electrical circuit. It also activates a relief valve, which is why your compressor goes psh when you shut it off, and that reduces or relieves the head pressure on the compressor, you know, actual pistons itself. That way it can restart. Otherwise it would be starting against a load and you wouldn't be able to do that. This is the side that regulates the tool pressure. So what this consists of is this part, which is the actual regulator assembly, or the valve assembly rather, that gets pushed on by this part. Alright, this part pushes on that and goes inside of this part, which has a thread that this articulates with on the knob itself. And of course there's a little spring and a little dome-shaped washer and a screw on the end of that. Whoops, sorry, not that one. On a screw in the end of that one, which keeps it from coming all the way out. So what happened was, you can see that that thread's all gone because it's cheap. And likewise on this side, it's not much better. So what I was doing is, I'm in the habit of relieving the pressure on this at the end of the day when I'm not using it. So I just walk by it and I turn it to the left and it, you know, bleeds the pressure off. I just back the pressure off normally, just keep this thing from having all that pressure on it and the spring. And I figured I was doing the right thing, but apparently because this is Chinesium metal and apparently not enough grease inside there either, lubrication, it just tore itself out. So essentially it went, you know, and stripped past the threads, and now I can't screw it in to put the pressure on this, because you turn these clockwise to raise the pressure, push that in, and give me tool pressure. And I got a bike on the lift, and it's a pneumatic lift, so I got to get this back in service. Now, I'm going to use my lathe for it, but you don't need a lathe to do this. That's why I'm showing you. You could do it with hand tools. And what I'm going to end up doing is, I'm going to drill this out for the tap drill size for an M10 1.25 thread pitch. And I have an M10 bolt here with the same pitch. I'm going to get this out of here so I have the total length. You can see that the inside of it has a feature, not a knurl, probably like a little mini spline that's pushed in there and glued. We're going to heat that up with the pen torch and just kind of wiggle it out so we can save this cap. And then what we'll do is we'll make a companion end, probably with the knurling tool in the lathe, that'll go inside there, and we'll glue it in at the proper length. One of the operations, we'll have to put that thread and drill and tap for this thread here for this little one, which I haven't measured yet, but I would assume this is probably M5. So anyway, let's get started. We'll fix this thing. I got it in the vise over by the lathe. I like this little vise. I got it at a antique store locally a couple of years ago. Handy for little stuff. So I'm going to take this pen torch, which is right here, and then we'll get in this hole. Get in the hole, and we'll heat it up just to a point, I think, where we can wiggle it out, like this. But, realistically, you could use whatever knob you want. You don't have to use this knob over again. I mean, if you're going to make the new piece that goes, threaded piece, you can use whatever knob you want on it. Leave the bolt side on, whatever. It doesn't matter. But I'm going to try to keep it this way because I like it. So let's see what we can do here. I'm just going to heat it up. And actually, this is an M5, and that screw that went in there was Loctited with like kryptonite Loctite. So I couldn't get it out without heating it. So I heated it up with a pen torch and it loosened up that Loctite, and I was actually able to take that screw out. So now we're going to be doing it for a different reason. We're just going to kind of heat this up. course, these things never want to stay lit when the heat's coming back at them. There it comes. Well, you get the point. It's got a little spline on it. Focus! Whatever you want to call that. That feature they cut in there so it'll grab. And that's really no worse for the wear, see? So, we're just gonna, you know, probably, I gotta measure this up, OD wise. I'm pretty sure that bolt is actually bigger than this size. Hopefully it is. That way we can run a knurl on it, shove it back in here. But what I need is the overall length of this. And if you're doing this with hand tools, you know, there's not a lot of precision here. Just measure the length of this bolt, whatever you want to call it, once you take it out. If you're going to use the knob again, of course. If not, then just use whatever knob you want, you know, at that time. So we're going to try to reuse the knob, as I said. So let's go ahead and we'll go over to the other bench, and we'll see what we can figure out to make a little layout and then cut this thing. Now, in closer examination, you can see here that these threads are actually in pretty good shape. So this was, in the hierarchy of materials, this is harder than that, obviously, and it just took the internal threads out. So I think this is an M8 125, but I'm pretty sure that this is pulled out larger than the tap drill for an M8 thread insert. Plus, there's not a whole lot of material there. I wouldn't want to trust that. I don't think it would last very long. You know, that would be one way to solve it, at least temporarily. You know, you got enough where you could drill it and tap it for like a helicoil, and then just use some red Loctite to lock the helicoil insert in place, and then use this over. But we're going to stick with the original plan because I think it's going to work better. Yeah, folks, without compressed air, I'm dead in the water, so this is the priority for the day. It's 0700 or so, and I got to get this done before I do anything else. So we're at about 940. No, it's not critical. About that length. And I don't think that this shank is going to be larger than this. Let's take a look real quick. The largest is about 400 thou, and this is at a little under that. Well, what we're going to do is, that's fine. We're going to just use the threaded portion anyway. As you can see, that's just fine there. And we'll just mark that off. And since the threaded portion on this particular bolt is larger than the shank anyway, we'll just knurl the crap out of that back area. And it should raise it up enough where we have enough real estate to go back into here, and it'll be glued in just fine. Like I said before, you can use whatever knob you want. So rather than use the calipers, not everybody's going to have a pair of calipers like that. The overall length of this guy is about 15/16. So that's what we're going to go with. Just going to cut that bolt down to size in the vise off camera, and then we'll move over and do our lathe work. We'll just give her a quick face. Unfortunately, I'm all out of aluminum can, like pop can, to wrap this up in the jaws, so I don't have it very tight. I don't want to screw threads up, but again, it's not a precision thing, so it'll probably be fine. I can always chase them with a die, but I don't want to make extra work for myself. Yeah, okay, so the next operation, I'm going to spin it around, and we'll drill and tap for that little screw that goes in the end. I'll double check to make sure that's M5. Pretty sure it is. The tap drill for M5, that's an M5 by 0.8, I think it is, thread pitch, is number 19 drill bit, or 165 thou. You know, you don't have to do it that. If you don't have all that stuff, just find a screw if you have a tap for, and just drill it and tap it even by hand and a drill, and you know, regular hand drill and a vise. It's not anything critical. It's just, as long as it's a little bit bigger than the inside of that housing that this threads into, which we'll show you here in a minute, it's going to be fine because it just keeps it from backing out all the way. It's just one of those things, all right? So you don't really have to worry about it. I'm just going to do it because I want to reuse that, that particular fastener. Now, I don't have a bottom tap for this, so we're just going to go pretty deep with it. I'd rather have it deeper than not deep enough, said the wife. Now a spring-loaded tap follower and all this rigmarole is certainly overkill for this kind of thing, but I got it, so why not use it? Whoops, let's lock the spindle. Actually, we'll just use the back gear for that. That'll lock the crap out of it. And we'll carefully get this going because this tap is not that sharp. Alright, now we got it started. I'll take it out of the chuck and go put it in the soft jaws of the vise, and I'll finish it up by hand off camera. Now naturally I'm going to have to use a bigger washer because my hole is going to be bigger to accommodate tapping it out for this thread. But that's no problem. Got you over there so you can see it that way, but it's not a big deal. Like I said, if you don't have a, any way to knurl or, distort the end in some uniform way, then what you do is just figure something out, put a bunch of, punch marks in it, anything like that if you're going to reuse this knob, to fit and fit snugly, and then just glue it in with whatever glue that you want to use. Alright, so it's no big deal. It's not going to the moon or nothing. Also, I did find some aluminum strips because there's a lot of tool load on this, or a lot of workload. I do like the knurlers that come down and provide their own pressure, from the top, kind of sandwich it in, but unfortunately I do not have one. So we're in back gear again, and we'll run it slow. The width of this is just, kind of a guess as well. It's just so wide, and we're just going to match it up to the one that was on there. Okay, take a look. Alright, so inside there you see that little, looks like a shoulder in the middle of it. And that is obviously to accommodate this, and they made this all together. I mentioned they shoved this in and molded it around it. We're going to get around that by drilling that out by hand, and then just pushing this in with glue once we clean it. It's definitely good size for that major diameter. But before we do that, let's go ahead and get that housing done and make sure this thing threads in there okay. And then we can finish this up by actually putting it together and seeing if it works. I got the housing chucked up. Luckily I'm able to get on this outer shoulder, and it goes into the grooves on the jaws and keeps it nice and true, you can see. So the tab drill for an M10 125 is actually 8.8 millimeters, and I don't have an 8.8, so I'm going to do an 8.5. And this is peanut butter material anyway, it'll tap in there. I don't know what the decimal or fractional equivalent, 11/32 or something like that, I can't remember, but just look it up if you're going to use something like this. If not, just use a bolt that's the right size. If you're doing this by hand without a lathe, just eye it up close as possible, drill it, tap it, and it should work just fine. I mean, like I said, it's not going to the moon. Not going to have any problem tapping this with anything just about. That's why the thread's pulled out in the first place, because this is some Chinesium grade aluminum alloy or whatever the hell it is, pot metal, and that centerpiece inside the knob is obviously some sort of steel, so it just wore it out. And had I realized that, I would have taken it apart a long time ago and greased it up or something, but I did not realize that. So now we're paying the price. And I don't know if I mentioned, there's a bunch of posts on different, I think one of the Google reviews for this air compressor, in fact, where there's several of them. I only read a couple of them because I'm looking for parts for this thing. They're non-existent. And so the reviews I read were all negative. The negative ones were all surrounding this piece right here, where I had it for 2 years. The regulator knob dealio crapped out. Another guy was like, I had it for a year. Good luck getting parts. Good luck getting somebody from Kobalt, actually, a person to talk to you, etc., etc. Now the other option to this is you can get a cheapo Chinesium whole new manifold, and it'll probably plumb in, and you have to rig up some sort of way to fix it, because this is bolted in, or screwed in rather, by the cover plate, which you'll see. You know, I guess that's another option to fix it, but you know, I think repairing this is actually pretty easy if it's not completely decimated or destroyed. And so yeah, I think it'll work just fine. So normally I'd blow this out. Whoops. But yeah, so now we got some decent threads in there, looks like. Good enough. Here's our replacement piece. It would clearly be going in this way, so yeah, that's good. Slight bit of play, like you'd normally expect. And she's about the same length as the original one, side by side. Maybe a little bit longer, but hey, that's okay. A little longer is better than shorter, said the wife. We'll try it out. Alright, that's in there good, and it's pretty straight. I took that same M5 screw I used before to take it out, and I pressed it in the vise, and it's super tight. Then backfilled it with some of this special glue from my kit that you saw in the VFR repair, the plastics repair. You can use any super glue. It's not going to work 100% anyway. This is probably some sort of a nylon, which that shit isn't really rated for, nor is super glue, but it's really tight in there. And if we put some leverage on it, you can see that it ain't going anywhere. With that knurl, it's got a tooth, so you just kind of have to play with it or make a new knob. That's all there is to it. So this has to be assembled before you put it back into the valve body here, or the manifold body. Don't forget your O-ring. I took it off to wire wheel this. So right now I'm just slathering in some grease, so we don't hopefully have this problem again anytime soon. And then we put this guy in all the way. Now there's supposed to be some Loctite on that screw where it locks this in so it can't back out all the way, but I'll be honest with you, I don't think you need it. I'm just going to tighten the snot out of it with an additional washer on it, and I think she'll be just fine. And it doesn't really matter if it's off a little bit. See, what happens is this little cup rests on that screw head, and that provides the force in, so this thing really is not unloaded much at all, so I really don't know why they used a Loctite anyway. But yeah, we're good and tight now. Good and tight. The German torque spec. These Chinese O-rings are about worthless, so you know, it is what it is, but you might as well reuse it. Try to be careful it doesn't roll on you. Probably doesn't matter. There was some white shit in here, which is obviously thread sealer, so we're, you know, like plumbing thread sealer, so we're going to put some of that back on. What goes in next, of course, is this little cap guy, like this. Whoops, not like that. Like that. That's better. Then a spring. Then this little plunger guy goes like this. And this is what it goes up inside this bore here, so we can kind of load this up. But let me clean all this off first. But then it screws into here, so let me get it up to that point, and then we'll torque her up and bolt her back on the compressor and see what we got. This has also been cleaned with a brass brush. Alright, I'm going to put it in a vise and get it tight and see how it feels. Alright, it's a little snug, but I think she'll work. This is all the way backed off. You back it off all the way, you can get in here with a pair of channel locks or whatever and tighten the crap out of this thing. Now we're going up against that spring. We should be pushing that valve. Maybe the more I work this, it'll be a little better, but yeah. Who knows? Get that grease moving around in there. Alright, pretty good. Let's put it in and see if it works. Okay, we're back in. This feels about right. Now she's dead empty because I had to bleed her down, of course, to take that hose off. So, let's fire it up and we'll see if it works. Alright, we're at max pressure. And there you go. Basically the same. It feels good too. I mean, it actually feels a lot better than the other one did. When you back these things off, you should hear it, hiss out. Yeah, because what it needs to be doing is essentially relieving the pressure between that main inlet and the discharge here. So the only pressure on it would be at that valve right there and not anywhere past it. That's the whole point for having this, and also to adjust the pressure. Now when you have a hose hooked up to this, and the hose obviously is the same pressure as your tool outlet, it'll go psh, because all that pressure in the hose is coming backwards out this valve here. That's why you don't hear that right now. So this is functioning properly. Plug the line in. We'll fill it up. Alright. And the same thing, back it off. Alright, so that's right where it needs to be. Let me put her back up. I'd say she's fixed. So that's it. How to fix a Kobalt, upright at least, air compressor, tool side pressure regulator on an air compressor. So hey, it's not impossible. You can definitely do this with hand tools. You don't need a lathe. Just modified operations based off what I did by taking a bolt, cutting it off with a hacksaw, knocking off any burrs. The back end really doesn't need to be all that flat. Just use the threaded end, the machine end of the thread, and then drill a hole, put a little tap in there, whatever size you want, don't really matter. Put a little screw so this thing again is held in so it doesn't back all the way out when you turn it, and then just do all the rest of that, and you'll have a whole new functioning unit once you drill and tap out that body, which is super easy because it's, like I said, this shit's peanut butter. Okay, so we're done. Thanks for watching. Don't just repair, restore. Let's go fix something else, like a VTX 1300. Yes, another one.